Hello, welcome to lesson 3.4 of Pre-AP. This is the introduction to limiting and excess reactants. We're going to first go over 3.4a as an example. I will then do two more examples and the rest will be homework for you to do. Okay, so we're going to start with question 1. It says draw particle diagrams representing the before and after states of the reaction you modeled. So you weren't here to model this reaction, but we're going to start here. I'm using red for oxygen. Remember, I'm going to draw 4 molecules of oxygens. Oxygen is diatomic, so I have 1, 2, 3, 4, but there's 2 each. So there's 4 diatomic oxygens shown here. I'm also going to start with 4 hydrogens. Hydrogen is also diatomic, and so I've got 1, 2, 3, 4 of those molecules in my before picture. Remember that every reaction is always accompanied with a chemical equation that is balanced. Now what we're going to do here is just read our reaction, changing our reactants into our product of water. Right? So it says 2 hydrogens. So I'm going to circle 2 hydrogens. Those are my gray open circles. Okay? And 1 oxygen. So let's just pick one of those. And those are going to bust apart. And in my after box, I'm going to be forming 2 waters. Okay? So the oxygen's going to break up into those, and then I'm going to draw them as little bent water molecules right there, right? So I took 2 hydrogens and 1 oxygen and formed 2 waters on this side. So then the question I can ask is, can you do that again? Do you have enough material? The answer is yes. If I take 2 hydrogens and an oxygen, those will break apart and we will form 2 water molecules. Can I do that again? Now this time the answer is no. And the answer is no because I have no more hydrogens to circle. I just have these 2 oxygens that are left over. Okay? So now it says write your own definitions of the following terms: limiting reactants and excess reactants. Okay? Words that you can use to describe these things: that limiting reactants, they limits how much product can be made. Another thing that limiting reactants can do is that they stop the reaction. Right? We couldn't make any more product. We ran out of stuff, and so the reaction stops. Limiting reactants are also the thing that runs out first. So in our example up here, right, all of these things apply to the hydrogen. The next term we have here is excess reactant. Excess reactant is what you have plenty of, or maybe the extra that's left over, right? Right, these are the leftovers at the end of a reaction. These things apply to the oxygen. I have these 2 oxygens left over. If they're left over, that makes oxygen my excess reactant. Now, abbreviations that I'm going to continue to use, limiting reactant I just say is LR. Excess reactant I abbreviate as X and an S. Okay? Okay, so as we continue in this fun activity, the next page is handout 3.4B, and I'm going to work out these first two examples. The next three will be for you. Okay? So in this example, we've got blue for magnesium, and red is still oxygen. We see that magnesium is not diatomic, but oxygen is. And every reaction comes with a balanced chemical equation. Okay? So just like we did on the front side, I'm going to circle and then draw my products as I go, right? So my reaction says I've got 2 magnesiums, so I'm going to circle 2 magnesiums and 1 oxygen, so those are going to go away, and I'm going to form in my reaction 2 MgOs, magnesium oxides. That's only 1 magnesium and 1 oxygen. So 1 magnesium will go with 1 oxygen. And I need 2 of those, so 1 magnesium will go with 1 oxygen. So there's my 2 MgOs there. Can I do it again? Sure. I've got 2 magnesiums, and it doesn't matter which one. I'll take the one in between. 1 oxygen. Those will break apart. 2 magnesiums, 1 oxygen will form 2 magnesium oxides. Can I do it again? Yes. 2 magnesiums and an oxygen will all bust apart, and they will form our new products of magnesium oxide, which I make 2 of each time. Can I do it again? Now when I go back, the answer is no, because I ran out, or I have no more magnesiums. That makes magnesium my limiting reactant. My extras must be the oxygen. And when I count those extras, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 extras. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, matter cannot be created or destroyed, and so that excess reactant comes over into my afterbox. Things that are helpful to also realize is that we made 4 magnesium oxides. 1, 2, 3, 4, 5. No, we made 6. I'm so sorry. We made 6 magnesium oxides. And we already counted them once, but there were 9 oxygens left over. All right, let's look at number 2. For number 2, this one doesn't give us any pictures, so we're going to have to read carefully, right? It says that we have 4 molecules of methane, CH4. And we're going to use this same color key that's here. So 4 molecules of CH4 means C is this black one, right? And around that black one, I'm going to have 1, 2, 3, 4 hydrogens. That's only 1 CH4, but this says we have 4 molecules of CH4. So I'm going to draw this 4 times. Now we're going to combine those with 6 molecules of oxygen. Remember that oxygen is diatomic, so I'm going to draw 6 of those. 1, 2, 3, 4, 5, Okay. Now that I have my starting picture, it says we need to balance the equation below. So 1 carbon and 1 carbon, 4 hydrogens and 2 hydrogens. So 2 times 2 is 4. That makes those hydrogens balanced. Now I've got 2 oxygens here in carbon dioxide plus 2 oxygens here in water. 2 plus 2 is 4 oxygens on this side. And so 2 times 2 oxygens is also 4. So that would be my balanced equation. Now that we have our balanced equation, which we always need for any reaction, and we have our starting image, this is like doing question number 1. Okay? I'm going to circle 1 CH4 and 2 oxygens. Those are going to bust apart, and when they do, they're going to form 1 carbon dioxide. That's C with 2 O's. And we're going to form 2 waters. So water is H2O. So 1 black, 1 black, 1, 2, 3, 4 white, 1, 2, 3, 4 white, 1, 2, 3, 4 red, and 1, 2, 3, 4 red. So that's our balanced equation, and that's what that looks like every time the reaction goes. So now I'm going to do it again. 1 methane and 2 oxygens will bust apart, and they will form 1 carbon dioxide and 2 waters. And then last time, 1 CH4 and 2 oxygens will bust apart, and they will form 1 carbon dioxide and 2 waters. I can't do it again because I ran out of what reactant, right? So I ran out of oxygen. My excess reactant, I can see it right here, is that CH4, which I'll need to redraw. Right there. All right, so now I would like you guys to complete this assignment 3.4b.